Ale, just in case you're talking, you're muted.
Oh, uh, thank you. I'm not sure what part was last.
You said hi.
Oh, okay. All right. Uh, yeah, okay. So let me start this again. So, hi everyone, this is the DRA support sync, August 5th instance. We have some items on the agenda for today. The main one is webs for 110. So the first one is CPU with DRA. Uh, Shija is going to be helping out with this web. Shrija, do you have any updates you want to share?
Yeah, I mean, nothing like I'm looking for reviews. So, yeah, just posted the design. I'm looking for reviews on this part.
Well, yeah, we can. Yeah, definitely. I'll go through this web and share reviews. Uh, the next one is device manager like policies. So the context for this web is we now have at least two or three different kinds of devices that are supported by DRA: CPU, GPU, host devices, and network devices. Um, while the APIs are descriptive right now, it could be hard for a user to come up um, with their own DRA shape. There is a lot of learning going on that a user needs to undertake to come up with a required DRA spec that they want. So the idea here is that just like how device manager or topology manager in kubelet gives nice policies around what kind of alignment you want or what kind of um, topology shape you want, we can have additional APIs on top of the existing APIs that can abstract the DRA spec part. So we will be looking at things like manage claim or auto claim, where the claim is generated by um, KubeVirt and managed by KubeVirt rather than user having to handcraft the claim and provide it to the spec. So that's what this web will be about. Hopefully, we can. My hope is to target 110. I'll reflect it here in the web. And John John Hull from Red Hat has expressed interest in collaborating on this, so we'll be looking at this web as well. I want to pause here. Does anyone have questions on this?
Um, hi, Ale.
Yes.
I will just I was talking with Vladik last week or maybe before,
Mhm.
and I think one of the things that he raised was that currently some of the topology, I will say, is expressed through the VM spec today, right? And how does that not collide with this? Like, if someone expresses a specific topology, how we are going to check that this is what it actually got and it's not messed up. So that was one concern I think that he had, especially with the CPUs, I think.
Right.
And my
So
and
yeah,
that just make one second point, and you can answer both, and that's it. And my question is um, is this option like I think the auto claim or manage claim sounds, I think it's we discussed it in the past to have something like that. But I wonder, can this be part of like, can it be in parallel to what KubeVirt controllers are doing? Like maybe another thing that will auto generate it per the desired spec anyway, so we will not need something like that. I just a question. I'm not really sure if that's it.
Yeah. So let me take those questions one by one. So the first thing about uh, the VMI spec currently addressing or having topology requests. So we've looked through the VMI spec, and the topology request mostly comes in the domain spec. Well, I think I'm looking at the wrong one. Yeah, if you go to domain spec has, not sure why. Give me 1 second, sorry. Not this. Okay, yes, I was clicking at the wrong link. So if you go to domain spec, there is a field called CPU, and inside the CPU struct, you have a bunch of options to, specify the topology. However, this topology is what will be reflected inside the guest, and it's not what will be requested from kubelet. What will be requested from kubelet right now is governed by what kind of topology manager or kubelet configuration you have locally on that node. So what I would what the thought process is behind these webs is, with DRA we can get much more granular on what we request from the infrastructure. So that is the part that these two webs will be targeting. And then once you get the specified topology, they will be reflected inside the guest based on the configuration here. So I don't think both of these fields will collide. So that's my answer for question number 1. Does that help answer the question, Eddie?
So I think I understood, but I think today, I mean today, how is it? This is a part, the details that I didn't check myself actually. How it is working today, like if you define here all the topology, how is it reflected in what
Right.
what we request today, not with the DRA, the regular thing. I think that was the question, is because today the controller controls, I mean, KubeVirt, I think, controls what we are asking for the pod to be assigned to something, and then
Right.
this is one thing. So now you are doing the second one. This is what under your control what you're requesting, right?
And so not really. It's a hit or a miss. So let me explain. So let's say this topology reflects you have 6 cores and 2 threads, right? 6 cores here and 2 threads. So in total, you are requesting 12 CPUs from the host that will be given to this Word Launcher pod. And then Word Launcher pod will convert this into the topology that will be specified here. So 6 cores and 2 threads. So in general, you'll be requesting 12 CPUs. The way this will work right now is when you specify 6 here and 2 here, Virt controller will generate a pod with requests and limits reflecting 12 here and some overhead, right? Let's say 12 and that overhead is calculated as half. So you'll get 12 and a half CPU. Now that will go to the pod spec. Then the pod will land on a node. And if NUMA topology awareness is configured on the node, then kubelet has a component called device manager and topology manager. That component will be activated and it will give you topology based on whatever its policy is. So it could be best effort, or it could be strict, or it could be none. If it is none, then you'll get whatever course you want. If it is best effort, then if a NUMA node core is available, then all of the 12 vCPUs will be in specific NUMA. And if it is strict, then it will be in one NUMA, guaranteed. If not, then the pod will fail. So that's what happens today. But it is not granular, and you can understand from the description that it is very fragile. Like the scheduler can say go to this node, but that node might not even have NUMA enabled. The topology might not be present, so on and so forth. So with DRA, all of this will be much more transparent, and you will be able to request the topology at the claim level, not at the kubelet level.
That sounds, you explained it well. Yeah, thanks.
Okay. Lee, I know you have your hand raised. Sorry, go ahead.
No, it's great. That was a great explanation. I just, when you were talking about expressing policies in KubeVirt, though, like from the description that followed after to Eddie, it sounds as if we are going to be making very kind of detailed requests, right? So in terms of the topology and NUMA and stuff, are you suggesting that some of that would be somehow generalized into a policy that KubeVirt would also know how to then kind of turn around into, an explicit DRA request? And my only concern with that is that surely that's something that could live outside of KubeVirt and would have utility outside of KubeVirt, potentially, that like a policy layer or something. So yeah.
Yes. That's a great question. So when we were discussing Web 10 design, this topic came up, like how do we make it easy for users to consume the APIs, the DRA APIs, right? And this idea of the device manager like policies was born out of that. Let me bring the appendix so I talk through the correct text. Give me 1 second. Okay, here we go.
Don't see anything changing on the screen. Oh, there you go. You're changing it.
Man, let me open it. So if you look at Web 10, there is an appendix. And in the appendix, there is, yes, future extension. Okay, so this is what we discussed in the past. So the API that we are thinking will look something like this. So under the resource claim, VMI spec resource claim, you have a managed claim with some kind of policy, right? So let's say for simplicity, we are not looking at NUMA right now, but we are looking to align GPU and NIC through PCI route or PCI bus ID, right? So in this case, the policy will be I want resources to be aligned on this specific attribute, and whatever resource embed this policy will be part of this alignment, right? So in this GPU 0, you see claim name as GPU NIC, which is connected here. And in this network, you see claim name as GPU NIC, which is connected here. Because of this connection, both the word controller or some centralized component know that these two devices are part of an auto-generated or managed claim, and they want to have aligned resources between them via this attribute. So the information in this spec is enough for some KubeVirt component to generate a spec, and that will basically make it very easy for users to generate advanced device alignment specs. Now you can also do a similar thing with CPU and NUMA alignment, and hence the first alpha version will specifically focus on exploring whether we can do device management and topology management things that kubelet expresses via this API, right? So that will be the first target, and then we can do another alpha to add other policies on top of that. So that's a bit of context. The main question, whether this should live in KubeVirt or outside, I would say there are specific KubeVirt related things that are very focused on virtualization. So for example, there is a field in the VMI spec CPU struct called IO emulator threads, right? That field gives extra CPU threads for doing IO emulation. That is very specific to KubeVirt. Things like this make this a KubeVirt project. But if we are able to generalize these APIs for something like pod, then we can take the exploration from here and go propose these APIs in Kubernetes. And even if we do that, it is a very valid approach, and we would be able to absorb those pod changes here in our spec as well. So that was the discussion we had between Ryan Hellesy and myself, and even Vladik was involved with some of this as part of reviewing this web. Yeah.
Okay. Yeah. Like in my head, I was thinking more like the generic kind of topology pass-throughs, like cases and alignment with NUMA and stuff that you could have utility with, just pod workloads and stuff. But yeah, I appreciate there's quite a lot in our API that is, the special cases and corner cases and stuff that we're going to have to handle as well. Like as a initial reaction to this kind of suggested API, it is quite a kind of deviation from what we have at the moment. That's not necessarily a bad thing. That is quite verbose to kind of for a user to even to express a generated policy like this, or a managed policy, sorry, or claim. We're asking them to kind of codify quite a lot there. Then up until now, rightly or wrongly, a lot of this functionality has been enabled through pretty limited attributes to get the behavior. So yeah, I'm not sure how I feel about asking folks to do all of this just yet. we're probably gonna have to go through examples. But yeah, if there's a way of us handling more of the generic stuff in a kind of more concise way, so for the topology pass through or for NUMA pass through even, that would be cool, and we could still have this expressive stuff when needed. Like I don't know how you would make it more concise for like the device example you've got here. But yeah, that's just they're my just initial thoughts just seeing this.
Right. So
Yeah.
I think this is the most advanced example we have here. The NUMA stuff, for example, could simply have a NUMA policy here, like how you have align policy. And because it is all CPU, it will just be referenced at one place. So it will be two fields that a user has to uh, specify. And then you get NUMA alignment in a spec-driven way rather than going through kubelet. I can come up with an example for NUMA for this construct. It will probably be the first thing we target because device manager at kubelet does exactly that. So yeah, I mean, as an action item from this, Lee, I can come up with a NUMA example, and then we can discuss um, whether it is simple enough or there is room for improvement there.
Cool, thank you. And just one final comment before I let Eddie come in with his. Like again, just from an API point of view, we'd be codifying like another way of doing something, right, in V1, in the VM and the VMI APIs. Yeah, I just wonder how we're gonna kind of eventually whittle this down, or if that's even something that we're gonna have to plan for. So just having, you know, the existing NUMA pass-through approach in the API, the existing dedicated CPU placement stuff as well. Like if we are going to kind of focus on DRA going forward, I think somewhere it would be good to write down the fact that, you know, eventually potentially we are going to have to kind of deprecate and remove the other stuff. And this will be the way that we do it going forward. That isn't that important. I just want to. It's just more stuff in the API, so we should be thinking about like what the future actually is and getting rid of the other stuff that we're now replacing.
Yeah, that makes sense. I think the correct path would be we explore this device manager policy here in KubeVirt. Then from our lessons learned on that, take this uh, to Kubernetes, deprecate device manager in kubelet. They will be very happy to not maintain that code anymore, and then come back, deprecate those fields here. That would be the ideal path going forward, but it involves a long journey. So we have to start somewhere, and this is the baby steps that we are taking.
Yep, thank you.
Yes, one more hand. Eddie, go ahead.
Yeah, I just wanted to ask, like, just I'm trying to imagine how this looks like, because the only thing that is a bit added here is it's a bit of noise from an API point of view, is these policies that you need to define at the VM level. So I wonder what. Let's say that I'm creating a policy, but I'm just deploying something on the cluster that generates this resource claims or these claims. Okay, for example, GB unique align, something like that.
Mm-hmm.
And then given this domain spec that you showed here, and network spec and everything, how why do I need to specify why do I need to specify manage claim and the policies here? Can't it just have a name? And because I installed in the cluster this managed claim component, managed thing component, then it will just auto-generate these claims per what it says it's needed, like per what the VM spec has, and per the policy that you write there. Why can we manage it outside of the VM? I don't need to manage each VM. I just manage general policies in this way. Can we do this like that? Or what is the con for that?
Uh, so let me see if I understand correctly. What you're saying is let's take this part and put it into a separate CR and a controller, right? Whenever that controller sees a VM with this CR name mentioned here, and that being referenced in the devices or network section, then it will automatically generate the claim and um, do whatever is necessary for this VM. Is that accurate
Yeah,
understand?
that's more or less. And then from my point of view, that means that I don't need to. I mean, every vendor can install their own things. Like I don't need to. We allow others to play this game as well. If like they can do it. Like they can auto generate based on this reference.
Yeah,
Something like that. Like it's totally external to the. It uses the exact same mechanics for with the resource claim, the regular one that someone else defines it, but you auto generate it based on the fact that you want to manage it.
sure. Yeah, we can do that, but I would argue that the goal of this app web would be to provide solution for device management, like the device manager like policies for Numa and other resource alignment. So we would have to provide a sample implementation, and if someone is more advanced and they don't want to use our sample implementation, then they can install their own thing, right? So
Yeah,
I
yes.
agree with you, but we should have one implementation of that component in tree.
Yeah,
Is
yeah, it needs to be. I don't know if it's in tree. It doesn't matter. The in tree thing is it's fine. The thing is about the expressing this in the VM or VMI spec and not letting the existing AP keep on being generic, and we just complement it with external mutation like the admission policy, stuff like that, that will or not do anything. Like they will generate what they needed from outside, and then you don't know that it is managed from a VM point of view. It doesn't know it is managed. The managed part is done outside. That you will auto generate these claims yourself, or KubeVirt will auto generate based on the logic that you want. But you do not try to manage the policies here. You don't want to configure them here. Something like that. That was my point. Because this policy, for example, tomorrow you want to align something else, you want to add NUMA, you want to add CPUs, memory stuff. You don't want to describe it here. You want to describe it in some other place.
Well, that's what I don't follow, because part of the description will be here, right? So you need to know what devices belong to that auto-generated
Yeah,
claim.
but that's under the device. That's fine. That like to specify in the GPU, for example, for example, here I will expect if I want to specify a GPU or a network interface to be specific to a specific NUMA, I want to say it myself. That's an option. Or if I want to say in the policy that they must align, for example, something like that, that's in the policy. But if you want to express something specific, you can do it either in the devices themselves. And if you want to do something generic, like what you gave an example here, the specific configuration in the devices, it's fine. But the policy, I don't have to define it here. I can define it outside. This is what I meant, I think.
Yeah, yeah. I mean, that's a valid approach. I can spend some time to brainstorm that and come up with pros and cons. Uh, we did, so when we were bringing up this particular spec, the reason why we had it here in the VMI spec is, if it is in VMI spec, then it's under KubeVirt control, and then you can have indirection from here. So let's say tomorrow Kubernetes has a SIG sponsored project that manages auto claims. Then you can rely on that controller and have an indirection on that policy from here. That's why we went ahead with this, that for now we will control the auto generation, and in the future we can give it to somebody else and still have a field that we can reference to. So I think we both of us are saying the same thing. It's just you're recommending that what if we start with that out of band approach to begin with. Uh, yeah, let me spend some time on thinking about the pros and cons, and we can discuss this further. Okay. That was a fruitful discussion. Let me see what else we have. We have one more web. VM scoped persistent resource claims. This is the enhancement. So this web is basically tying the resource claim spec to virtual machine spec, and the virtual machine controller will create the resource claim, and it will basically have persist when stopped field, and when this is true, it will persist the template. That's the problem it is solving. The big problem we had with PVC style. So for example, for SIG storage, to use DRA devices for NVMe and other use cases, you need storage to persist across pod lifecycle, because VM can be suspended, the pod will go away, resource claim will go away, and there is no no storage anymore for the VM to come back up. So how do you solve this problem? This web is focused on that. I have yet to review this web in depth. The questions I have is, this works at a template level, and even if you have persist equals to true here, the underlying resource claim will be garbage collected, so the storage will go away anyway. So it's not clear how this API will help in solving that problem in the first place. But again, I have just skimmed through the API. I have not had a chance to review this. So I'll review this and figure out if that problem is being solved, or we need to modify this. Yes, Lee, go ahead.
Yeah, just a quick one, because I'll review this as well. But wouldn't this lead to us nesting this stuff in two different locations potentially, and two different controllers potentially fighting over stuff? There's the potential for the VMI controller to suddenly care about one of these resource claims. Like, I would, just looking at it quickly, I would rather just have these template entries in one place, and then somehow have it codified in the VM, to persist these somehow, and to pass that signal down to the VMI. How you do that, I'm not sure, but yeah, again, it's just another place where we're potentially asking folks to kind of template these things in the API, and so that the VM API is starting to get more and more packed out with things. So yeah, if possible, I'd avoid duplicating the nesting.
I
Yeah,
don't
I
even,
hear.
just saying that I don't really understand what is lost, like, because the resource claim is assigned on the template spec, so I'm lost here.
Okay, so let me take a step back and share. So let's assume that our resource claim uh, is mounting NVMe devices which has storage and which has data that a VMI has stored into. Now there is a architectural issue in Kubernetes that if a pod is deleted, then the resource claim will be deallocated automatically. Uh, because that happens, uh, let's say if a VM is using that NVMe storage via DRA and the VM is suspended, then the underlying VMI will be deleted and the underlying pod will be deleted. Because that happens, the resource claim will be deallocated and the storage that was used by the VM will go away. It will not be persisted.
Okay, but that's a decision that so I don't understand where is this limitation coming from, that it's the resource claim is like reference only by the pod and it will be cleaned up if the pod is gone. Or
It's coming
where
from
is
Kubernetes.
Kubernetes is so Kubernetes is not allowing persistent claims to exist?
Yes.
But it supports templates, so I don't understand, which is
The
not.
template is just a class, like it's a class and resource claim is an object, right? So the template just encapsulates the spec. The resource claim is what instantiates that device allocation.
Okay, so how is this going to solve it? Because it will keep a pod alive? I don't understand.
Yeah, that's my uh, the exactly what I expressed earlier, that I don't follow how this API will exactly help. I need to dig into the web. Uh,
Okay, I understand. Usually what I saw, it's like the claim itself is depending on some other device, real device, and that device needs to persist. And if you create a new claim, then it better reference to that one. Like the claim should be smart to go back to the original device. That's it. It's not related to having the claim alive. Or make sure that the claim is not removed with the pod. That's it.
No, I think what we have to do to solve this problem is create a sidecar pod that references this claim, um, that references this claim for the lifecycle of the VM, not the VMI, and then share that resource claim between that sidecar pod and the original VMI Vert launcher pod. So that way, if the Vert launcher pod, keeps going away and coming back because of suspend and resume, then the claim will still exist because it is tied to that sidecar pod, and the Vert launcher pod can simply share that claim with the sidecar when it comes up. Uh, that is the workflow that I think and is the only workflow that I think will solve this problem, but I'm not sure it is reflected here in the web. Just
Which Where is the sidecar? What you said? Where is it living in? Sorry, in which pod?
so every VM starts with a pause pod, right? Some background pod which references the persistent resource claim forever until
So
that VM
okay,
is
you want
deleted.
to use the pod as like an anchor or something
Yes,
for the VM. That's like a very nasty one.
but
But
that's the only way to solve this problem. Otherwise, you have to re-architect the entire DRA stack.
I don't know. It sounds to me that the idea that claim is one-to-one reference with the pod, or I mean, it lives with the pod. It's not fitting virtualization in this sense. Or it doesn't support the persistency that you're asking for. Right?
Right.
Yeah, it's
Yeah.
like it's a very extreme measure what you're suggesting here, to always keep a pod for VMs.
I think what I'm saying is if you want persistent claims, either you have that anchor pod or you go to Kubernetes and relax this requirement that the pod, the resource claim should stay there when the pod is gone. It has to be one or the other. So yeah, depending on what approach we decide, we can um, have that discussion.
Will they agree to something like that? To have like a to decouple the strong relation with the pod, so the claim will still be there.
That was so. Remember, DRA had like 3 or 4 different versions in its journey to beta and GA. One of the really early ones had that ability. The API had the ability to persist the resource claims even after the pod is gone. But for some reason, it was stripped off, and the newer version of DRA does not have that ability anymore. So I am not sure if they will agree with this, considering that the field was present and it was removed before beta and GA.
Yeah,
But yeah,
we have quite a strong use case, and like if we can find another use case just in vanilla pods for that to be a thing, we can potentially lean on them. But I think our use case is pretty strong for it.
yeah. Yeah, one of the arguments that I expect is if you really want that persistent behavior, why not just use a PVC to manage that NVMe storage? Uh, I don't know if I have answers to that. Like, what benefit would a persistent resource claim get us compared to a persistent PVC that exposes that NVMe storage via CSI?
Well, if we cannot answer that, then they have a point, right? So why would I want to have a persistent claim if I can do the alternative? If we don't have the answer, then
Well,
then
I'm saying before we go make that case with them, I think we should brainstorm between SIG storage and us, like what benefits this API gets us. At least at the top of my head, I don't know immediate benefits, but maybe SIG storage has some thoughts that was not discussed.
you mean between the requesting something, not about the API, just the fact that you want to request a persistent claim vs just a PVC, right?
Yes,
So it's not about the API, it's about the idea of a persistent claim vs just a simple PVC. Why is that better?
correct. So um, to summarize, the open question is if you have a NVMe device right now, currently, because this persistent resource claim is not a thing, you would anyway manage it via a PVC and put it in a VMI spec, right? What are the pros? Like what functionality that is missing that we need resource claim or persistent resource claim to be a thing? That I'm not sure of. And I'm not sure who or where to raise that question. Maybe SIG storage. Okay. That brings us to the end of the web uh, discussions for for 110. Does anyone else have topics to discuss today? Okay, looks like not. Thank you everyone for the discussion. I will ask Andrew to upload this meeting so we have it recorded, and I'll also summarize the notes from what I remember here in this document. Thank you everyone. See you next time. Have a good day. Bye.
Thank you. Bye.
Thanks, bye.